Good morning students. Welcome you all for next generation learning. Today we are going to see the subject physics class 10. Chapter number 11 Human Eye and Colorful World. Topics case study based questions and assertion and reason type questions based on the topics 11.3 Refraction through a glass prism, 11.4 Dispersion of white light by a glass prism, 11.5 Atmospheric refraction, 11.6 Scattering of light. The question number 1. Read the following and answer any 4 questions. The spreading of light by the air molecules is called scattering of light. The light having least wavelength scatters more. The sun appears red at sunrise and sunset. Appearance of blue sky, it is due to the scattering of light. The color of the scattered light depends on the size of the particles. The smaller the molecules in the atmosphere scatter smaller wavelength of light. The amount of scattering of light depends on the wavelength of the light. When light from sun enters the earth atmosphere, it gets scattered by the dust particles and air molecules present in the atmosphere. The path of the sunlight entering in the dark room through a fine hole is seen because of scattering of light by the dust particles present in its path inside the room. Do you understand this paragraph? If you take our earth, this is our earth. The earth is made up of atmosphere. The atmosphere is a heterogeneous mixture. It consists of air molecules, dust particles, water droplet. So, some particles are smaller in size, some particles are larger in size. So, this is the earth. This is sun. When the sunlight enter into the earth atmosphere, the light is reflected in many directions. This is called scattering of light. So this scattering depends on the two factors. One is the size of the particle and another one is the wavelength of the light. You know that the sunlight is made up of 7 colors. The sunlight is made up of 7 colors. Violet, indigo, blue, green, yellow, orange and red. So the sunlight is made up of 7 colors. Here the red have longest wavelength and violet have shortest wavelength. So when the white light, that means the 7 colors, fall on these particles, the smaller particles scattered smaller wavelength. The larger particle scatter longer wavelength. So, the scattering of light depends on the two factors. One is the size of the particle and another one is the wavelength of the incident light. Here the sunlight is made up of 7 colors, that means violet, indigo, blue, green, yellow, orange, red. Here the red has the longest wavelength, violet has the shortest wavelength. The smaller particle always scatter the shortest wavelength. The large particle always scatter the longer wavelength. Due to that, we can see the sky appears blue color, and during the sunrise and sunset the sun appears reddish because of this scattering of light. And see, the spreading of light by the air molecules is called scattering of light. The light having the least wavelength scatters more. That means the violet, indigo, blue have the least wavelength. Mostly the blue, violet, indigo color only scattered. The sun appears red at sunrise and sunset. Appearance of blue sky, it is due to the scattering of light. The color of the scattered light depends on the size of the particles. The smaller molecules in the atmosphere scatter smaller wavelength. So, small particle scatter smaller wavelength. That means violet, indigo, blue. The amount of scattering of light depends on the wavelength. So, from this we can say that the scattering of light depends on the wavelength also. When light from the sun enters the earth atmosphere, it gets scattered by the dust particles, air molecules present in the atmosphere. We know that. And the last point they given, the path of sunlight entering in the dark room through a fine hole is seen because of scattering of sunlight by the dust particles present in its path inside the room. See, this is a dark room. For in this dark room, one small hole. When the sunlight enter into the small hole, the particles present in the room scattered the sunlight at many different directions. Due to that scattering of sunlight, we can see the path of the sunlight, and also we can see the particles present in the room. How we can see the particles present in the room? Because of scattering of light. So this is given in this line. So you have to answer for the following question. To an astronaut in a spaceship, the color of the earth appears. Option A red, option B blue, option C white, option D black. Consider this is our earth. This is our atmosphere. When the astronaut in the spaceship, that means they are far away from our earth. Maybe they are here. In up to this only we have the atmosphere. Above this there is no atmosphere. So when the sunlight enter into this empty space, vacuum, there is no particle. If there is no particle means there is no scattering of light. If there is no scattering means here the sky appears only black color. Do you understand what I am saying? This is our earth. It is made up of atmosphere. The atmosphere consisting of many particles. But if you go up, there is no atmosphere. So in astronaut or here, if there is no particle means the sunlight enter into this space, there is no scattering. If there is no scattering means the sky appear only black color. So the correct answer is black. The second question, at the time of sunrise and sunset, the light from the sun has to travel option A longest distance of atmosphere, shorter distance of atmosphere, both A and B, D cannot say. See, this is our earth atmosphere. This is a horizontal line. When the earth surface and atmosphere meet, this line is called horizontal line. So during the sunrise and sunset, the sun is below the horizon. The sunlight has to travel for the longer distance. So at the time of sunrise and sunset, the light from the sun has to travel longest distance. Option A is the correct answer. And it was shown here. See, the sunlight has to travel longer distance. When it is below the horizon, the sunlight has to travel longer distance to reach the earth observer. The third question, the color of sky appears blue. It is due to the refraction of light through the atmosphere, dispersion of light by air molecules, scattering of light by air molecules, all of these. See in this image. This is earth, this is atmosphere. The sunlight consisting of 7 colors from the violet to red. So when it enter into the earth atmosphere, the air molecules present in the atmosphere scatter the sunlight. Mostly the violet, indigo, blue only scattered because they having the shorter wavelength. Due to that, the sky appears blue here. So the correct option is option C, the scattering of light by the air molecules. The next question, at the time of sunrise and sunset, blue color scattered, option A, blue color scattered and red color reaches our eye. Option B, red color scattered and blue color reaches our eye. Option C, green and blue scattered and orange reaches our eye. Option D, none of these. You know that this is our earth. This is our earth. Okay. The observer is standing here. The sun is here. So when the sunlight enter into the earth atmosphere, mostly the shorter wavelength are scattered away. Finally, the red color only reaches our eye. So that during the sunrise and sunset, the sun appears red. So the correct answer, blue color scattered and red color reaches our eye. This is the correct option. See here. Here the blue family of shorter wavelength are scattered and red only reaches our eye. But in a second option they given the red color is scattered. No, here the red color is not scattered. So the correct option is blue color scattered and red color reaches our eye. Option A is the correct answer. The fifth question, a danger signs made red in color because the red light can be seen from furthest distance. Option B, the scattering of red light is the least. Option C, both A and B. Option D, none of these. Option B is the correct answer. The red light is scattered least. See in this image. Here which color is least scattered? The red only least scattered. So when the signal signs are red color, the red light will travel longer distance and also it is least scattered by the particles. So option B is the correct answer. The next question, read the following and answer any 4 questions. Atmospheric refraction is the phenomenon of bending of light on passing through the Earth atmosphere. As we move above the surface of Earth, density of air goes on decreasing. Local conditions like temperature etc. also affect the optical density of Earth atmosphere. On account of atmospheric refraction, stars seen appear higher than they actually are. Advanced sunrise, delayed sunset, oval appearance of the sun at sunrise and sunset, stars twinkle and planet do not twinkle. Do you understand this paragraph? Okay. First you have to know what is meant by atmospheric refraction. This is our Earth. It is made up of atmosphere. Not only it is a single layer, it contains many layers. The temperature and particle, the number of particles are varying from one layer to another layer. So, this is our Earth. This is sun or star. When it enters, this is a vacuum and this is a air. So, when the light travels from one medium to another medium, it undergoes refraction. Due to that refraction, the star seen appear higher than they actually are. Advanced sunrise, delayed sunset, oval appearance of the sun at sunrise and sunset. When we go up, the density of the layer is decreasing. Do you understand this paragraph? What is meant by atmospheric refraction? When the sunlight enter into the earth atmosphere, it undergoes refraction. This refraction is called atmospheric refraction. And the atmosphere consists of many particles, and the density of the particles and the temperature of this layer is not stationary. It can change from time to time. Due to that atmospheric refraction, we can see the star appear higher than they actually are. Advanced sunrise, delayed sunset, oval appearance of the sun at sunrise and sunset. And stars twinkle, planet do not twinkle. The first question, due to atmospheric refraction, apparent length of the day. You know that this is our earth, this is a horizon line. When the sun is below the horizon, it undergoes refraction. Actually, the sun is below the horizon. Due to that refraction, the sun appears above the horizon. So we can see the sun before 2 minutes. Actually, sunrise. The same thing happened during the sunset also. When the sun is set, it is below the horizon. It undergoes refraction. Due to that refraction, the sun appears above the horizon. So we can see the sun after sunset in 2 minutes. So for sunrise 2 minutes and sunset 2 minutes. So totally the length of the day is increased by the 4 minutes. So due to the atmospheric refraction, apparent length of the day is increases 4 minutes. Second question, apparent position of the star appears raised due to. See this image. This is a real star. When it enter into the earth atmosphere, it undergoes refraction. If you draw the straight line, this is an apparent star. And see the position of the real star and apparent star. The position of the apparent star is slightly higher than the real star. Why? Because of this refraction. So, option A, atmospheric refraction. Option B, scattering of light. Option C, both A and B. Option D, none of these. The correct answer is atmospheric refraction. Due to the atmospheric refraction, the star appears raised. The third question, the sun appears oval shaped or flattened due to option A, dispersion, option B, scattering, option C, atmospheric refraction, option D, cannot say. See, this is our earth. This is a horizon line. When the sun is below the horizon, it enter into the earth atmosphere and refracted. If you draw the backward line, and from the bottom is refracted, and from the top also it refracted. So if you draw, the shape of the sun is flattened. And in this picture they given clearly. See here. In when is below the horizon, the sun is in a round shape. Due to the refraction, the sun is little flattened. That means it is ovaled. So due to the atmospheric refraction, the sun appears oval. The next question, twinkling of stars and non-twinkling of planets is accounted for by scattering of light, dispersion of light, atmospheric refraction, none of these. The twinkling of a star and non-twinkling of planets is accounted by the atmospheric refraction. The fifth question, in absence of atmosphere, the color of the sky, if there is no atmosphere means there is no scattering of light. If there is no scattering of light means the sky appears always black. See, this is a black. The next question, assertion and reason. Following questions consist of two statements, assertion and reason. Answer these questions selecting the appropriate option given below. Option A, both A and or are true and or is the correct explanation of A. Option B, both A and or are true but or is not a correct explanation of A. Option C, A is true but or is false. Option D, A is false but or is true. The question number 1. White light is dispersed into its 7 color components by a prism. Yes, when the white light passing through the prism, it is dispersed into 7 colors. So white light is dispersed into its 7 colors components by a prism. So assertion is true. The reason: different color of light bend through different angle with respect to the incident ray as they pass through a prism. Yes, see in this diagram, this is the incident light. When it enter into the prism, it is dispersed into 7 colors at different angles. That means the red has least deviation, the violet have most deviation with respect to the incident ray. So the reason is the correct. So which one is the correct answer? Option A. Both A and R true, and R is the correct explanation of A. This is the correct answer. The second question. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. Yes. See, here we take pure water and colloidal solution. The colloidal solution consisting of your particles. So when the laser beam enter into the colloidal solution, the particles present in the colloidal solution scattered. Due to that scatter, we can see the path of the light. This effect is called Tyndall effect. So they given the phenomenon of scattering of light by the colloidal particles give rise to Tyndall effect. This is the correct. Reason: the color of the scattered light depends on the size of the scattering particles. This is also true, but it is not correct explanation of A. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect is the correct. The same thing, the color of the scattered light depends on the size of the scattering particle. We already learned that. The blue color, the shorter wavelength always scattered smaller particle. Larger particle always scatter the longer wavelength. So the color of the scattered light depends on the size of the scattering particles. Both A and R are true, but R is not the correct explanation of A. But both the sentences are correct. In next question, a rainbow is sometimes seen in the sky in rainy season only when observer's back is towards the sun. Yes, when we have seen the rainbow during the rainy season, we have seen the rainbow in the sky. How? See, this is observer, this is a rainbow, and this is a sun. The sun is always the back of the observer, and the back of the observer is towards the sun. Then only we can see the rainbow. Okay, see, this is a sun, this is a rainbow. How we can see the rainbow? If you are looking in this direction, we can see the rainbow. If you look in this direction, we can see only the sun. So the observer's back is always towards the sun. Observer front is always towards the rainbow. So this is a correct. Reason: internal reflection in the water droplet cause dispersion, and the final rays are in backward direction. The sunlight enter into the water droplet. the refraction taken place, because this is air and this is a water. After refraction, it goes inside the water droplet. It is disposed into 7 colors. The 7 colors are totally reflected inside. Again it come out from water droplet to air. It undergoes refraction. Then it is disposed into 7 colors. Due to the internal reflection in the water droplet cause dispersion, and the final rays are in backward direction. They are in backward direction. So option A and the assertion and reasons are true, and R is the correct explanation of A. This is the correct answer. The question number 4. Danger signals are made up of red color. Yes, we know that the danger signals are made up of red color. Reason: velocity of red light in air is a maximum, so signals are visible even in the dark. This is correct. For here, the velocity of the red light is maximum. Yes, the red light has the longest wavelength. The wavelength is directly proportional to the velocity. So the red light has highest wavelength and it has highest velocity. So signals are visible even in the dark. No, not only for the velocity of the red light is maximum. The velocity of the red light is a maximum and it is least scattered by the particles present in the atmosphere. Due to that least scattered only, we have made the signals in red in color. It has highest wavelength is one reason, and another reason is it is least scattered, but they given signals are visible even in the dark. Not this line is wrong. If in a dark means, no, this is wrong. The velocity of the red light in air is a maximum is a correct, and if they are given it is the least scattered means A and R are true. A is the correct explanation of R, but they given so signals are visible even in the dark. This is wrong. So both A and R are true, but R is the not correct explanation of A. In question number 5, assertion: the sky looks dark and black instead of blue in outer space. Yes, when we are in outer space, the sky looks dark instead of blue. Reason: no atmosphere containing air in the outer space to scatter sunlight. Yes, exactly correct. In the outer space, there is no atmosphere. If there is no atmosphere means there is no particles. If there is no particle means there is no scattering of light. If there is no scattering of light means the sky appears dark only. So both A and R are true. R is the correct explanation of A. The next question, assertion: the stars twinkle while the planets do not. Yes, the star twinkle but the planet do not twinkle. Reason: the stars are much bigger in size than the planets. This is also correct. Comparing to the planet size, the star size are bigger, but due to the bigger size, the stars not twinkle. The stars twinkle because of atmospheric refraction. The stars twinkle due to the atmospheric refraction, not the size. But in a reason the stars are much bigger in size than the planets. It is correct. Comparing to the planet size, the stars are bigger in size. Because of that size, the stars are not a twinkle. Because of the atmospheric refraction, the stars to be twinkle. So both A and R are true, but R is not correct explanation of A. This is the correct answer. The next question. The sun appears flattened at the sunrise and sunset. Look here, during the sunrise and sunset, the sun appears flattened. See the shape of these two. Here, the shape of the sun is a round. Here, oval. So the sun appears flattened at the sunrise and sunset. During the sunrise and sunset, the sun appears flattened. The reason? The apparent flattering of the sun's disk at the sunrise and sunset is due to the atmospheric refraction. Yes, due to that atmospheric refraction, the sun appears in a flattened. So both A and R are true, and R is the correct explanation of A. The next question. Blue color of sky appears due to the scattering of blue color. Blue light has a longer wavelength. No. The blue family light having only the shorter wavelength. Blue color of the sky is due to the scattering of light, but it is here the reason they given blue light has the longer wavelength. Not. This is wrong. So A is true, but R is false. See here the blue color is scattered, so the sky appears blue. But see the wavelength, here the wavelength of the blue is shorter wavelength. So A is true, but R is false. Thank you for watching. Please practice these questions for your examination. Thank you all.